After you read the problem very carefully, my advice is to highlight or underline the claim that you're trying to test. So here we're trying to test the claim that the mean amount of sleep for adults is less than 7 hours. Keep in mind that this is referencing the population, so we want to know what the mean amount of sleep is for all adults. So let's go ahead and identify that population parameter, mu, which is the mean amount of sleep. All right, and again, this is for all adults, referencing the population. Okay, let's go ahead and take what we highlighted or underlined and let's write that original claim using symbolic forms. So I'll put it in quotations here. We're testing the claim that mu is less than 7 hours. Okay, so notice that, and I'm going to keep track that this is the original claim, the OC. Notice that the original claim contains the less than symbol, so this lets us know that the original claim is going to sit in the alternative hypothesis. So let's go ahead and write down the 5 steps for doing a hypothesis test. The first step being writing the null and the alternative hypothesis, so the null and the alternative hypothesis. And then our second step is to calculate that test statistic value. Our third step is to then calculate our p-value for that specific test statistic. And then our fourth step, I'm going to squeeze it in here, is to make a decision about the null hypothesis claim. So we're either going to reject it or not reject it. And then the fifth step is to write our conclusion. Okay. So we're testing the claim that on average, adults are sleeping less than 7 hours. This lets us know that we're testing a claim about a mean value. Notice that nowhere in the problem do we know what the population standard deviation sigma is. So because it's unknown, we're going to use a t distribution. So let me write that correctly. We're going to use a t distribution with degrees of freedom of n minus 1. So here in this problem, I'm going to use red here to highlight our sample data. N is 12, so our degrees of freedom is going to be 12 minus 1, or I'm going to use a degrees of freedom of 11. Okay. Also notice that we have some sample data here. But you don't have to worry about that sample data because I've already calculated all the sample statistics for you and given it to you in the problem. But if this information above was not given to us, then what you would need to do is put this information into your calculator and then use one variable stats. So that calculator function and one variable stats will then give you all of those sample statistics. Okay, so let me erase that and keep that in mind so that we can use the calculator function to get our test statistic and p-value. Okay, let's continue. So here, let's go back to step 1. I'm going to write my hypotheses. So mu less than 7 hours is the original claim. It is also our alternative hypothesis. Therefore, our null hypothesis is the assumption that the mean amount of sleep is 7 hours. And then what we're going to do now is I'm going to go straight to the calculator and use the calculator function t-test, okay? Now, if you want to use formulas, go back and take a look at the video for the first question on this assignment. But here, I'm going to go straight to the calculator function. It's going to ask us to put in our mu naught value, which is that 7 hours, and then go ahead and type in all of your sample statistics. The other thing that you got to put in is you have to put in the alternative hypothesis. So when you get to that part of the calculator function, make sure you match it up with the less than symbol. Your calculator is then going to give you a test statistic value, which I'll write in green here, of negative 0.2897, which we can round to negative 0.29. And it's also going to give us a corresponding p-value of 0.389. What this means is when I am looking at that sampling distribution of sample mean values at the center, if the null hypothesis claim is true, we expect that every time I take a random sample and calculate that sample mean value, it should be 7 hours. Or if it's not exactly 7 hours, maybe it's a little bit more than 7 hours or a little bit less than 7 hours. But if the null hypothesis claim is not true, then we will find that our sample statistics will either be all the way on the right tail or all the way on the left tail, where it will fall in our critical region. Now here, because the alternative hypothesis has that less than symbol, our critical region will be all in the left because we have a one tail left tail test here. where our significance level, we're using 0.05 here, is going to be in the area of that red shaded region that I just shaded in red here. If you use your calculator function, inverse t will give us the critical value on the left here. So using your calculator, that gives us a critical value of negative 1.795. Now here we can see that our test statistic for our sample mean of 6.8 hours. So we go, okay, yeah, 6.8 hours, it's less than 7 hours. But we can see here from the test statistic that that t-value of negative 0.29 is really not that far away from the center where that t-score is 0. So it doesn't fall in the critical region because that test statistic is not more negative than negative 1.79. And so here we can already see what decision we're going to make in step 4. So here, if you're using the p-value method, we can say since our p-value, which is 0.389 is greater than our significance level, right, of 0.05, we will fail to reject the null hypothesis claim. Okay, it could still be true. And then also visually we can see here that our p-value, that 0.387, it is an area that is much greater than that red area of 0.05. So that also confirms our conclusion in step 4. So let's go ahead and write our final conclusion that addresses the original claim. Here we would say that there is not sufficient evidence to support the claim that the mean amount of sleep for all adults is less than 7 hours. Okay, and again, this makes sense because if we go back to step 1, let me use blue here. Notice that our original claim is that alternative claim. The evidence doesn't support that because we ended up not rejecting, not rejecting the null hypothesis. So therefore, the evidence does not support our original claim.